Hello everyone, my name is Ibrahim, and along with my 9 partners of teamwork, members of Group 2, 4, and 5, we are CSIT sophomores in the Egyptian Japanese University of Science and Technology. In this video, we aim to create a program to solve second-order ordinary differential equations.
We are going to be using the MathWorks compiler since the SymPy library is already imported. If you're going to be using a different type of compiler, you might have to import SymPy as SP. Now let's get started with the code. First of all, we will define y as a function of x. In order to do that, we're going to sym y. Here's x. Here you go. That's how you define it. Here. Now we want to define the coefficients of y double dash, y dash, and y as input functions. In order to do that, we first of all write coefficient 1. It's going to be equal. Then we're going to use the input function. And in order for the user to know which value he should input, you're going to write him a message. That's why you're going to be using double quotations. So here we're going to write coefficient.1. And don't forget the semicolon. Now this line of code is going to be repeated 3 times since we have 3 coefficients. This is going to be the second coefficient, and this the third. Now we want to write the right hand side of the equation, which is going to be result, is going to be equal. Since it's already given, it's also going to be an input value. The message is going to be result dot value. Now we're gonna define ODE itself, the ordinary differential equation. So in our first step, we multiply the first coefficient with the second derivative of y with respect to x. The second coefficient is going to be multiplied with the first derivative of y, and the third coefficient is going to be multiplied with y itself. Now how should we write that? First of all, we're going to write ODE is equal to first coefficient of 1 is equal to, is multiplied with derivative. For the derivative, we're going to use the function diff. It's going to take y, x, and 2, since it's the second derivative, and we're going to add that to the second derivative, second coefficient of 2, which is multiplied with the first derivative of y, diff. No, I want y and x. And we're gonna add that with the last coefficient, coefficient 3, times y. We're gonna equate it with the result. In order to solve this equation, we're gonna use the dissolve function, which is ySol x is equal to dsolve you're going to give it ODE y is equal to 1 equal to, there you go. And you could also plot the graph of the ordinary differential equation using EZplot. Get ySol. There you go. And now we're finally done with the code. Now it's time to run it. Now that we have the code and it's done, we write the value of the coefficient over here. We're going to be using in order to test the code, we're going to be using questions from the problem set given to us by the professors of the Egyptian Japanese University of Science and Technology. So the first question is question number 1. We have y double dash, so 1, enter. Hold on, there's x. 1, enter. And then the second coefficient is plus. Oh, actually, it's not there. It's plus y directly, so that's going to be 0 for the y dash. And then 4, enter. And then result is equal to 0. There you go. Now it's solved, and this is their table. This is our graph. Let's try a different question. Let's try question 5. Question 5 is 4, and wait. 4, enter, and minus 4, enter, and plus 2y, 2, enter, is going to be equal to 0 as well. There you go. Solved, and that's our graph. Mathematics is a science until the stage of vision. Then it is turned into magical fiction. Accordingly, we decide to illustrate a visualization for our second order ordinary differential equations by plotting a data into a graph, as shown using EZplot. I thank all my professors, Dr. Ahmed Abdel Malik and Dr. Yahya Hilmi. Additionally, I thank my teammates Arwa Fawzi, Maryam Al-Shirbini, Nuran Galal, Hussam Al-Din Khalid, Maryam Fathi, Sama Assam, Shahd Sami, Basil Nasser, and Ahmed Ashur. I hope this video helps many students in their studies, and thank you for watching.